Hello there. Today we will be doing word problems that involve finding the rule of quadratic equations. The prior knowledge that we recommend would be that you can recognize and solve the three following forms of quadratic functions. The first one is the general one, the vertex one, and the factored form. Now, without further ado, let's get started. Word problem 1.1. Flora and Katja are playing with a jumping rope in the schoolyard. They're standing 2 meters away from each other, and they're both holding the jumping rope at a height of 0.75 meters. Lynn is jumping the rope right in the middle of them. Now, when the rope passes below her, Lynn must jump higher than 10 centimeters to avoid touching the rope. We find the function rule for the parabola that approaches the shape of the rope at that moment. Okay, so now how do we solve word problems like these? Well, we will be using Polya's method, which consists of 4 steps, of which the first one is that we get to understand the problem by listing all the useful data that we are given, making sure that we convert the data into the same unit or we'll be making mistakes, and also to state what we are asked to find or what we have to work towards. So let's get started. So this is our word problem, and we are given that there are 2 girls, Flora and Katja, and they're playing with a jumping rope. They're standing 2 meters away from each other. That seems very important, so let's list this. And they're also holding the jumping rope at a height of 0.75 meters. We'll be listing this. And we know that there's a 3rd girl, Lynn, who is jumping the rope right in the middle of them. We'll be listing that. We also know that Lynn must jump higher than 10 centimeters to avoid touching the rope. So notice that the unit here is centimeters, but the rest of the given data is in meters. So make sure that we convert this into 0.1 meters. Next up, we are asked to find the function rule for the parabola that approaches the shape of the rope at that moment. So, which means when she jumps over it. Next up, we will be devising a plan. By sketching the problem to get a good understanding of what the problem is about, and to check if the word problem actually belongs to something that we have a known method or formula for. Let's go ahead and do that. So this is our given data. And so we have the 2 girls, Flora and Katja, but we're not told where exactly they are located. But we do know about the 3rd girl that she's right in the middle of them. The middle makes us think of something. Maybe we could place her on the y-axis. So let's go ahead and do that in purple. Okay. Now, next up, about Flora and Katja, we know that they are 2 meters away from each other, and Lynn is in the middle. So we move from the y-axis 1 meter along the x-axis in both directions. And let's go ahead and do that. And so we end up right there. We also know about Flora and Katja that they're holding the jumping rope at a height of 0.75 meters. So we go upward 0.75, thereby determining the position where they were holding the rope. And next up, the position of Lynn. Well, we know that she must jump higher than 0.1 meters. So the rope will be right there. She'll be right above it, anywhere. But that doesn't matter. Now we have 3 points, and we will be sketching a parabola through those 3 points. There you go. So that looks pretty good. And next up, we want to find out what we have. So we have a parabola, 2 points on it, and we have, what's point L of the parabola? We call that the vertex. So we have the coordinates of the vertex, and we know that the general coordinates of a vertex are h and k. Now, does that remind you of something? Do we have a function rule we could use? Well, yes. There is the vertex form of the quadratic equation that we can use, as can be seen there. All we'll have to do is we have to plug in the values of the coordinates for h and k, and to find our leading coefficient a, we'll be plugging in one of the points on the parabola that we are given. So let's go ahead and do that. Our plan looks solid, and we can move on. Okay. The first thing we do is, we said we were going to start with the vertex form. And this is the general form. We'll be plugging in the coordinates like this. Okay, for h and k. Next up, we will simplify. Looking good so far. Now we still have the leading coefficient a to find. Now in order to do that, we can take one of the points of the parabola and we can fill the values of those coordinates into our function for f of x and x, or x and f of x. We'll be taking point k. You could have taken point f as well, but it's easier to calculate using this point. So we'll be plugging in those values and we solve for a. We end up with a equals 0.65. So now we have all the information we need to plug the value of a into our earlier equation or a function rule, and we end up with this. Now, is this it? Well, yes, we were asked to find a function rule, so let us use a full sentence to formulate our answer. The function rule for the parabola that approaches the shape of the rope when Lina jumps over it is f of x equals 0.65x squared plus 0.1. Very nice. Now next up, we still have to look back at our answer and check if it makes any sense and if it's correct or not. Let's do that. We'll be using the TI. You can use any graphing calculator, and we'll fill in our equation right there in the first line and graph it. Oh, whoa. This doesn't exactly look like the parabola we sketched, but no worries, because it's because of the window settings. So let's just adjust the window settings to something more suitable to our parabola, and we end up with something like this. Now this looks much better. Now let's check a few points. When x equals -1, y equals 0.75. That is correct. When x equals 0, y equals 0.1. That's our vertex. Correct as well. And when x equals 1, y equals 0.75. And with that, we are done. All right, now let's move on with the second word problem, 1.2. We're dealing with a similar situation, so they're still playing with the jumping rope, but the only thing that has changed is that now we're being asked to find the function rule for the parabola that approaches the shape of the rope the moment the rope is right above Lina's head. First, we go and understand the problem, and this is the word problem. Now, as we can see, most of the information has remained the same, so we can just list that. What we do know from last word problem is that we have a function rule of the rope from back when it was below her. So we'll be adding that. This will be of good use to us. Also, this time we're being asked to find the function rule for the parabola when it's above her. So this is the only difference. Let's go ahead and devise a plan. We use the same sketch of our parabola at first, the one that we found the last problem. And this time around, since a rope keeps turning, we will be reflecting this rope. But where? Well, we'll be reflecting it over line FK. And we end up with this. Now, what do we know about this red parabola? Well, we can say that about the shape of the arc, that it hasn't changed at all. So the absolute value of the leading coefficient A remains the same, 0.65. On the other hand, now it has turned into a concave down parabola, which means that the leading coefficient will be the negative. So negative A equals negative 0.65. Okay, we'll be using this information. We still know that Lina, or the axis of symmetry, is still x equals 0, which means that the h in our vertex will still equal 0. But this time, we don't know k. Okay? So we know that the values of a and h are given, which means we could probably end up using our vertex form again, like this. However, this time we don't know what k is. So in order to find k, we will be plugging in the coordinates of one of the points on our parabola, once again, either f or k, and then we'll be able to solve for k. Okay, let's carry out this plan by starting off with the vertex form, which you can see here. We plug in the leading coefficient along with h. Now we did this, okay? Now we simplify. That looks pretty good. Now we still have k left to find. In order to do that, we will be plugging in a coordinate of a point of the parabola for x and f of x. So we'll be using point k once more for easy calculating. So when we fill in, we plug in those coordinates, we end up with this, and we solve for k. Now here, k equals 1.4. We have the value of our k, so all we do is we plug all of the known values into this rule. And this also seems like our final answer. So we move on by formulating this answer using a full sentence once again. The function rule for the parabola that approaches the shape of the rope when it is right above Linna's head is f of x equals negative 0.56 x squared plus 1.4. Of course, we have to look back at our answer to see if we have done everything correctly. We'll be using our calculator again. We plug in our function rule into the second line and we graph it. This is looking pretty good so far. And let's check some points. When x equals -1, y equals 0.75. That is correct. When x equals 0, y equals 1.4. And this is also our vertex. And when x equals 1, y equals 0.75. And with that, once again, we are done. Now, for our last word problem, we have the following. The hops of kangaroos are parabolic in shape. One kangaroo jumps 4 meters and is more than 75 centimeters above the ground over a distance of 2 meters. How high did it jump? First, we go in and try to understand the problem. First, we know that the hops are parabolic in shape. This is very important to us. Second, we know that the kangaroo jumps 4 meters. Okay? And it is more than 75 centimeters above the ground over a distance of 2 meters. We'll be adding this, but beware, 75 centimeters, look at the units, it's not the same as our other data, so we will be converting that to 0.75 meters. Next up, we were asked to find how high the kangaroo jumped. So the height. Okay, next up, we devise a plan. Okay, so what do we know? The hop is parabolic in shape, okay, but the kangaroo jumps 4 meters. Now logically, we'll be starting at the origin, and we'll be moving 4 units along the x-axis. And we land in point B. We'll be drawing a parabola through those 2 points like this. Next up, we know that the kangaroo is 0.75 meters above the ground over a distance of 2 meters. This means when rising, it will reach that height, be above it, and when falling, it will reach that height again. And that distance is 2 meters. So, we'll be drawing it like this, and we know that the height is 0.75 meters, so we can draw this line. We end up with 2 points of intersection, C and D, but we don't know anything else about it yet. So, we can try to figure out something else. We know that since the jump is 4 meters, and we know that it's a parabola, if we divide 4 by 2, we'll end up with an axis of symmetry that is x equals 2. Okay, as can be seen in purple. This also means that we immediately have found the h value or h coordinate of our vertex. So we can place our point, our vertex right there, the vertex 2, k. Next up, trying to determine the position of points C and D, we know that we have to start from the axis of symmetry and over a distance of 2 meters, which means 1 unit in both directions. At a height of 0.75 meters, we end up right here, and now we can comfortably and decisively determine the position of those points. We also have points A and B there. Now what are those? They're the points of intersection of our parabola with the x-axis. So what are they? Well, they will be our roots. So let us summarize this. So these 2 roots A and B seem very important. This lets us know that x1 equals 0 and x2 equals 4. Now, thinking about roots, and we don't know the vertex, maybe there's another form we could use. Do we know such a form? Yes, indeed. It is the factored form. That's the one that features the roots. Okay? What we will do is we'll be plugging those roots into this function, and we still have this leading coefficient a that's left, and we can calculate it by plugging in the coordinates of one of the points that is on our parabola, either C or D. But that's not the end yet, because we still need to find the value of k, of our vertex. So we'll be doing that by, remember, k equals f of h. If you don't remember, you better refresh that a little. So this plan seems quite solid. Let's move on by carrying it out. So we said we were going to start with the factored form, as can be seen right here, and we will be plugging in our roots 0 and 4, as can be seen here. And now we simplify a little bit, like this. I could simplify it more, but because it makes calculations a bit easier, I'll just leave it here. Now we have to find our leading coefficient a by plugging in the coordinates of one of the other points of on our parabola, either C or D. We've chosen C. So if we plug in those values, we'll end up with this, and now we solve for a. Okay, we end up with a equals negative 0.25. So we plug the value of a into our rule, and we end up with this. Are we done yet? No, because we still need to find the value of k of our vertex. How do we do that? As we've said, we'll be doing f of h, and in this case, h equals 2. So we'll be calculating f of 2. And we end up with k equals 1. And now we have all the information we need to formulate our answer. So we'll use a full sentence. First of all, we know that the maximum of our parabola is 2, 1. Thus, the kangaroo has jumped 1 meter high. Next up, we'll be looking back at our answer. And once again, we take our calculator, plug in this equation, we graph it, might want to adjust the window settings a little, and we check the points. Now when x equals 0, y equals 0. Very good. When x equals 2, y equals 1. That's our vertex. That is correct. And when x equals 4, y also equals 0. And with all of that, we are done.